Okay, welcome to the first audio lecture that we'll be running for the remainder of this semester. We're up to task 3, the master production schedule. So today is basically looking at what the MPS is and how we'll be applying it to the tutes. Worth 15%, so it's a fair amount, and it's also a little bit complex to get your head around, but it's better to learn through experience and trial and error than through theory. So, as we recall, we had fabric from overseas. We had our 7 suppliers. We then built a transport calculator for both sea and air freight, and now we're just about to use those calculators in ordering fabric from overseas. We're going to spend a couple of weeks on this in the tutes. So, a master production schedule is a plan to produce or process a product in a given period of time, also known as, if you like, the brains of the supply chain. So it's got all the information pertaining to where the product is, where the garment is, where the fabric is, how much is in the distribution centre, how much is on an aircraft or on a truck, what's in the retail store, sell rates, the works. So in nowadays it takes the form of computer software, but it can also be paper-based, or it was in the past paper-based. But it's from here that we can start to pick out information that's pertinent to our business operation. The objective of an effective master production schedule will give production planning, purchasing and management the information to plan and control the manufacturing. So in short, if you don't know when the fabric's arriving from overseas, you can't employ casuals to work in your factory to make the garments. Equally, if you don't know how much you've sold in a retail store or your current stock levels, then going back up the supply chain, you can't manufacture the appropriate amount or send out more stock. So an effective master production schedule will allow you fundamentally to plan, and that's the key point. So on the test, apart from asking you what the definition is, or you'll need to select a definition, planning is central. If you can plan your supply chain, you'll get a much more efficient supply chain. We don't like surprises in our supply chain because it translates into higher costs. So we need to, what it does is you've probably got the idea, tie the overall business planning and forecasting together in one. So there's a couple of software programs here, and I'm going to run through one in a minute, but if you're planning to go into third year, you do one whole subject just on Apparel 21, which is like a master production schedule, or the MPS is part of the whole system which controls the supply chain for a particular range. I'll just run through one that we've pulled off the internet, Indigo 8 Solutions for Fashion. This gives us a sort of a good idea of what it does. And very briefly, let's assume we've got 100 wholesale customers, 8 staff and 1 agent, and they're a fashion designer based in Sydney. The first thing they'll do is they'll start to design their product from a body of information. So they, in this case, let's say for example, they're using 12 fabrics and 25 trims. So they'll mix and match to come up with a range, or a number of styles in this case, that they can apply, all from this one computer software program. So everything's already in the systems. So you might have a situation where the system is programmed to not allow you to use cotton and another fabric, for instance, for maybe because they don't go together, or they've got different care labeling requirements. So the system will tell you if you're making a mistake. So they choose their product, or they put their design for the product together, and it comes out in a computer file. That file, along with the spec sheet, gets sent off to sampling, all automatically. You just press send, and the manufacturer who's running your samples is also presumably plugged into this same computer software, gets alerted that you want a sample, and it puts it together. It also then will pick up the pricing from that and any other costs you want to feed into it, and end up giving you a sell price and a recommended retail price for the garment. Then goes on into if you like, the promotion of it, and it will automatically publish it on a website that you've already designed earlier, iPads, Excel spreadsheets, depending on what format you want and to who you want it to go to. And then finally, well, not finally, but you get sales coming in from our retail stores or our online stores. Again, all of the information about the sales, time of day, payment type, whether it's credit card or cash, all gets recorded by the computer software program, which then allows us to run analytics to see if we can pick up particular trends for certain garments or certain stores or times of day, whatever. And then we go back up the supply chain. The system can then place orders with suppliers overseas in, say, India or China. Um, and not only does it place orders, but it'll calculate what we call these critical paths. It'll work out the best time of day or week to deliver those items based on demand and forecast from virtual stores, and generates purchase orders as well coming from that. So if we need to buy another component, perhaps a trim for the garment, well, it will just generate automatically the order and it gets sent off electronically to that factory. And it also will assist in delivery of the goods, which is kind of the part that we're looking at in this whole assignment, rather than the other sections, which is covered perhaps not electronically but in other subjects. So it gives you an example of an integrated supply chain that uses an integrated software system, of which the MPS is one part. As I said before, Apparel 21 is an Australian based one that's also used by some companies. Key is it integrates or ties it all together. If all your suppliers are also accessing the information through the same software, it makes life a lot easier. And at the other end of the spectrum, if you take the marketing aspect and the promotional campaign for your garments, they're also plugged into this MPS and can start planning their campaign. So they make sure that their advertising, their billboards, displays all coincide with delivery dates of garments coming from overseas or being manufactured here in Australia. No point having a great campaign if you haven't got the products at the right time, at the right place to have them available. So again, it ties it back into the planning. Also increases the efficiency and accuracy of companies' manufacturing because you have zero waste. If you remember the 7 wastes from last year, by being able to plan, you're ordering just the right amount of fabric at the right time, at the right place. So again, that's coming from, where is it here? The Toyota system, the just-in-time system, eliminates waste. Coupled with the Kanban system or the ticketing system that's used, you don't have excess stock. And that's particularly important in fashion because unsold stock in fashion kind of goes off a bit like milk does, except you can't drink a garment. So what do we feed it, or how does this whole system work? We've got inputs and outputs. So basically it's a bit like your cat. You feed it and you get output from it. It likes you if you feed it the right food. In the case of an MPS system, we feed it information like forecast demand, how much we think we're going to sell, that's going to come from last year's sales, cost to make the garment, cost to store the garment, customer orders already in the system, so in case we've already promised to satisfy a client, that goes into the master production schedule. The current level of garments we've got in our supply chain, or fabric in our supply chain, or trims, the supply lot size, which is whether we want garments in batches of 10 or 20 or 30 or 100, so we tell it what we prefer there. The size of production, as in the scale, how much production we want to have. And lead time capacity is how long between when we place an order and we expect it to be fulfilled. So we feed all of this into the computer system, and magically it produces answers for us. And it tells us that we need to produce 5,000 units or 10,000 units. It tells us how many staff we're going to need to make that many garments. It tells us how many garments we're going to be able to promise at any given time. One of the key critical aspects of a business is not only having the garments, but being in a position where if you're asked, can you supply 5,000 garments in these size ratios, you have to be able to respond yes, and the quantity in a pretty short period of time. Otherwise, if you have to go back to the office and you have to calculate stuff, your competitor might get in ahead of you. And projected available balance. So how much stock are we going to have in August? How much in September of 2015, 2016 going forward? So we can again forecast that way. And from this information, we can start to plan. Oops, not ready for that yet. Now, did I? Just one more, there's an article here, you can have a look at it. It's on the Forbes site, have a look at it. But basically, it's, we took the just-in-time system, which was a manufacturing-based system to make cars more efficient, evolving from the 50s, 60s and 70s, and then Zara comes along, picks up the idea and says, can we apply it to fashion? And more or less, they adopt the same system with fast turnaround times, etc. But I think you're all pretty familiar with that. Let's pause. Okay, I was just missing a slide, that's why I've put it in. Now, a couple of things it produces for us, or it allows us to calculate, is things like the inventory turns versus inventory carrying costs. So I'm going to ask you about this on the test, where inventory turns is the number of times stock is replaced in a given period. So if you've got one stock turn a year, that means all the stock in your shop gets sold and gets replaced. That's one stock turn. If you have 12 stock turns a year, it means fundamentally you've got 12 deliveries per year, replacing your stock on a monthly basis. On this axis we have the inventory carrying cost. This is the cost to store the goods. And so in case of 1 million, 2 million, so in effect you could say it's the rent on the distribution centre. If we have one inventory turn a year, we need to have a massive warehouse that's going to cost us $6 million, because you've got to have a year's worth of stock sitting in the warehouse to then deliver to the retail store. But if we have more turns, then the rent or the distribution centre gets smaller, until finally we can go to something like 10 turns, which is many deliveries, which means we can have a smaller distribution centre. So the idea, what the master production schedule can do, is can work out the optimum level, the number of turns versus the cost of storing those goods. So there's no right or wrong answer. There's just there's just the most economic answer for your particular product range or brand or company. If we look at carrying costs and order costs, again I'm going to ask you about these. So carrying cost is the cost to store the goods again. Order cost is the cost to place an order. So this is the cost to pick up the phone and place that order. And you may remember this from last year. We did it last year, so it's just a bit of a reminder. So if we look at carrying cost curve, positive relationship between cost and size of the order. The more I order, the more it's going to cost me to store those goods, because we've got more goods to order. Order cost, on the other hand, is an inverse relationship where the less I order, 200 units, the more it's going to cost me. So if I order more goods, the order cost comes down. And again, if you recall, I used the telephone call as being an example of the order cost. You can pick up the phone to order one garment, or pick up the phone to order 10,000 garments. The phone call costs the same. And our overall objective is to get the total cost curve at its lowest point. Final one I'll show you is a reorder level. So in our distribution center, we have time on our x-axis, 1, 2, 3, 4, 5 periods. We can call it 5 weeks if you like, and number of garments. And the behavior in the distribution center is that at the start we have a DC full of garments, 4,000 units, and then as time goes by, the stock decreases because it's going out to the retail stores and being sold, until finally it gets to zero. A truck arrives, fills up the warehouse, we're back up to 4,000, and we repeat the pattern. Empty the warehouse, full, empty it, full. The critical line is this reorder point, because we have to, as stock hits this level, which is say 1,500 units, which is week 3, I think, 3.5, then that's when we pick up the phone, and place a call. Remember I was saying we place a call here? Because you don't want to ring up here because it's going to take the truck 2 more weeks to get here. So we ring up 2 weeks before we run out of stock. And that's our reorder point. Runs out of stock, but in the meantime the garments are being manufactured. Just as we run out of stock, the truck arrives and we're back up again, and then there's our trigger point. So these trigger points of 1,500 units is what the computer program works out for us. A small business does it in their head because they've got experience, hands-on experience. They kind of know how long a delivery is going to take, and work that way. Big business has to use systems like these to calculate reorder points and reorder quantities and inventory levels. So, how does this relate to us? Well, we have to set a daily manufacturing production target for the entire year based on forecast demand, and input that information into our table. So we've got 3 components to our master production schedule, which you've got in yours. So there's a whole heap of formulas we've got to work on in here. We have a manufacturing center where we're going to make the garments, distribution where we're going to store the garments, and international shipments where we're ordering fabric from overseas. The way it works, international shipments is we're ordering fabric, big rolls of fabric like here, and they come into our DC center. From the distribution center, the fabric is then sent to our manufacturing outlet, again in Australia. Remember, distribution and manufacturing for our assignment is going to be in Australia. The finished garments are then sent back to the distribution center where they're stored, packed perhaps, and then reconsolidated to be sent to the various retail stores where we're sending them. So that's our master production schedule, or that's the material flow of goods is what we call it, which is the physical flow of goods. And the way we represent it numerically is with the international shipments being this part, so the first part, columns A, B, etc. The distribution center is represented by the second component, and manufacturing reflects the third part. So there's lots of numbers in this one, but if you're a visual learner, try to relate the numbers back to this flow. If you understand the flow of fabrics and garments, it helps you understand the numbers. And the point of these exercises is, as I said in week 1, it just gives you a good feel for what logistics is and how it works. Okay, so these ones I think we'll do in class in the tutes. Yeah. Okay, thank you for that. I'm going to ask you in the tutes what you thought of the video. I can try to improve them some way as we move forward.